Welcome back. This is Mr. Greenstein's Geometry. We're in section 12.4, and we're in the third out of three videos talking about probability of disjoint and overlapping events. Let's use the formula to find the probability of A and B. So we have 200 students in the senior class. 113 are either varsity or on the honor roll. There are 74 seniors who are varsity athletes and 51 who are on the honor roll. What is the probability that a randomly selected senior is both a varsity athlete and on the honor roll? So let's take a look at the way that we could solve this problem. First of all, the total number of seniors is 200. The total number that they're varsity or they're on the honor roll is 113. We know the number that are on the varsity are 74, and that there are 51 that are on the honor roll. But we don't know what is the overlap. What is both A and B, varsity and honor roll? The way that we do it is we use the probability of A or B is equal to the probability of A plus the probability of B minus the probability that they're both happening at the same time. So we take that and we just do a little algebra and we subtract this, or we add this to both sides. So then we end up with that over here, and we subtract this from both sides. So we end up with that over here. So now we just start filling in the probabilities. The probability of being a varsity athlete is 74 out of 200. The probability of being on the honor roll is 51 out of 200. And the probability of that they're either a varsity athlete or an honor roll is 113 out of 200. And when we calculate all this out, we get that 12 out of 200 are seniors that are athletes and are on the honor roll by just using this equation. Let's use a trait diagram in this case. The American Diabetes Association estimates that 8.3% of people in the United States have diabetes. Suppose that there's a simple diagnostic test for diabetes that is 98% accurate for people who have the disease and 95% accurate for people who do not have the disease. So then they give this test to a randomly selected person. What is the probability that the diagnosis is going to be correct? Now remember, it's 98% effective or accurate when you do have diabetes and 95% accurate when you do not have diabetes. So we're going to use the full population of the United States. We're going to say that 8.3% or 0.083 are going to have diabetes, and not having diabetes is all the rest. So that's just out of 1. We just subtract 1 from the other. The probability that the diagnosis is correct if you have event A, which is that they have diabetes, then is 98% effective, and 2% that it's not. If you don't have diabetes, it's only 95% effective to show that it is correct, and 5% will be incorrect. So let's just pick out the correct diagnoses, that is, that you have diabetes and that it chooses you correctly, or you don't have diabetes and it chooses that you don't have it correctly. So what we'll do is we'll take the probability of event B is equal to the probability of A and B plus the probability of not A and B. And that's just following these parts of the tree. So if we look at probability of A and B, well, the probability of A and B is first 0.083 times 0.98, and that will give us 8.1%. And the probability of not having it, and event B, which is a correct diagnosis, is going to be 0.917 times 0.95, which is 87.1%. So what we do is the probability of having a correct diagnosis is that we take 8.1% plus the 87.1%, and we get 95.2% is the chance that you will have a correct diagnosis of diabetes. And that concludes this video. We will continue this conversation in class tomorrow.